Okay, we're back to, again, Chapter 6 on bonds in Managerial Finance class. Back to bonds here. Bonds represent long-term debt issued to the public in small units, usually $1,000. So a corporation raising $50 million, think about all the zeros there, through a bond issue would need to issue about 50,000 bonds. In other words, $50 million divided by $1,000. Now that assumes those bonds are issued at what's called par value, and we'll look at those definitions very soon. Now look at the reason that a company would want to issue bonds as opposed to going through a bank is generally speaking because it's going to get a better rate and better terms through that. By going directly to the public, in some sense, you're cutting out the middleman. Although, in fact, you're going through a middleman. It's going to be the investment banker that's going to assist in jumping through all the hoops. Because when you go and offer any types of securities to the public, the Securities and Exchange Commission is going to have you comply with a number of regulations. But anyway, the idea is this about bonds, is that by taking this $50 million and slicing it up into little pieces of $1,000 each, then you've got a broader market. The bank that wants to lend you $5 million can still do that. Or the foundation that has a lot of money and is looking for some fixed income securities, they can put that kind of money in. But you've also got the opportunity for somebody who maybe only has $5,000 or $10,000. They can also be involved in that issue. And so in broadening the market, it actually helps to enhance the sellability of it, and results in, with a broader market, all else the same, lower interest rates, a better price and lower rates. Now here's another number of bond terms that we need to become familiar with. The par value, the amount to be repaid at maturity. It's that $1,000 that per bond that I mentioned in the previous slide here. Par value, this is one of those things where you want to write these things in your notes. The par value is also known as the face value and represents the future value in terms of our time value of money calculations. The coupon rate is the contractual annual interest rate on the bond. On a $1,000 par value bond, an 8% coupon rate would mean the bondholder receives $80, that's PRT, principal times rate times time, $1,000 times 8% times 1 year would give you $80 annually. But by and large, corporate bonds don't pay annual interest at one time. They pay it in semi-annual installments. And so in this case, it would be essentially 4% or $40 every 6 months. That coupon rate also has some other names. It's sometimes called the stated rate, sometimes called the contract rate. And so these are terms you want to write down and just be familiar. A particular problem or an article that you're reading, might not use the same term all the time. Well, they certainly are. Those are valid terms that may be used in various contexts. Term to maturity, the number of periods until the bond matures. Most of the time, bonds are going to be issued. They're long-term investment or borrowing, so they're going to be more than 1 year. Let's say 5 years, 10 years, 15, 20, those kind of amounts. They don't have to be even 5 years, but let's assume for our purposes they're going to be 5, 10, 15 years or longer. But the term to maturity then is going to be the number of periods until the bond matures. So you want to be thinking in terms of, if it's a 10-year bond, that's actually 20 semi-annual periods. The market rate, also known as the yield to maturity, represents the interest rate the market is using to discount, that is, to determine the present value of those interest payments plus the face value, the par value, to determine the present value of the bond. In other words, it represents the market's required rate of return on that bond. The market rate also, of course, is known as the yield to maturity. We'll find that it also will represent the internal rate of return from an investor's perspective. We actually realize that I've said this before a number of times, that every time you have a buyer, you have a seller. Every time you have a borrower, you have a lender. And every time you have an investor, for instance, in stock of a company, you have an investee, that is the company issuing that stock. So you want to keep this in mind, that when a company borrows money, it is making a promise to someone that it's going to pay them back. And so the company is getting the proceeds of the issue, and accepting the obligation to make those interest payments plus the face amount at maturity. On the other side of that transaction is someone who's paying the price of that issue, and they're going to be receiving the interest payment stream, the annuity, and the lump sum at maturity. Well, let's see how bonds are valued. Since a bond provides cash flows in the form of both a stream of payments and a lump sum at maturity, then you can see that a bond's value is calculated as the present value of the sum of those two things. Thankfully, the calculator can work these problems really very easily, and it's just a matter of knowing how to set the problem up, knowing what the inputs are, and of course being able to use the calculator, as I think most of you can. Let's go through an example of a bond valuation, or I should say a bond evaluation problem, and I'll tell you more what that means in just a moment. But assume that Applied Materials has outstanding an issue of bonds with the following terms. Actually, we could think about this as it has it outstanding, or even I could have worded this to say, let's assume Applied Materials is issuing these bonds. The par value is $1,000. Coupon rate is 9%. The bonds have a term to maturity of 10 years, and the current market price is 91. Now, in bond terminology, prices are typically stated as a percentage of par. And since the vast majority, for our purposes, let's say all corporate bonds are issued with a $1,000 par value per bond, and so 91% of $1,000 is $910. It's something just to get used to. If a bond is trading for $85, that's $850. If it's 101, that's $1,010, and so on. It's one of those things you just get the hang of. Okay, given this information, if you buy this bond for $910, you're going to receive the coupon payments of, let's see, 9% times 1,000, that's 90, but it's payable every 6 months, so it's equal installments, semi-annual installments of $45 until maturity in 10 years for a total of 20 interest payments. So you just want to keep in mind, regardless of what the problem might say, you're going to assume that the standard arrangement for bonds, for corporate bonds, is for semi-annual interest payments. Notice here that coupon rate really is only used to determine the periodic, that is the semi-annual cash flows. Okay, is this a good investment? We're going to have two basic problems right now, or let's say one basic problem with bonds, trying to evaluate whether bonds represent a good investment. Let's say that you've determined that an appropriate required rate of return is 9.5%. Now that 9.5% represents the discount rate that you would use to bring those cash flows back to the present. So another way of looking at it, and this really goes back to Chapter 10 where we talked about the determinants of interest rates, we found that the interest rate really, or the rate of return on any security, can be understood and discussed in terms of three components: the real risk-free rate, which we designated as I star, a premium for inflation, which we designated as IP, and a premium for risk, which we designated as RP. It's the sum of those that make up the rate of return on any particular investment. And by and large, when you're looking, say, at the different rates on corporate bonds, mostly the difference in yields is going to be a matter of risk. Now, risk, you might recall, can be broken down into three basic components. There's default risk, there's liquidity risk, and there's maturity risk. Actually, that maturity risk comes back again in this material here. But let's go ahead with the example. And again, we want to evaluate this bond using this required rate of return of 9.5%. Okay, we've got two basic approaches. We've seen these before, and we'll see them again and again: a present value approach and an IRR approach. With the present value approach, we want to estimate what the bond is worth and compare it to what it costs. And if it's worth more than it costs, it's a go. If it's worth less than it costs, it's a no. IRR is really a similar type of, let's say, analysis, except we're actually solving not for a value, but for the rate of return that one would earn if they bought this bond at the market price. And we call that the IRR, the internal rate of return. We then compare that to the required rate of return, And if the IRR is greater than the RRR, it's a go. And if the IRR is less than the RRR, it's a no. Well, let's look at this problem then, how we would value this. When I thought about working this out in stages to kind of lead you along, but if you want to try to solve it on your own, just stop the video and go back and see how you can do. But anyway, here we see the model. The payments are $45 annually. Again, that's the 9% coupon rate applied to the $1,000 par value. That's $90 per bond. So, excuse me, $90 per year divided into equal semi-annual installments of $45. N is 20. I is 4.75%. Where does that come from? It's the 9.5% market rate divided by 2, again, because we had to convert that annual rate to a semi-annual rate. Notice we've got two parts here again. I had to break it down into two separate lines just to get it in this on the slide. And I've shown the separate for no good reason, really, shown the value, for instance, 573 as the present value of the interest stream, and 395 as the present value of that $1,000 face value. In sum, that bond is worth $968. And so we would say this bond is worth, that is, has a present value of $968 given a 9.5% required rate of return. Now here's the evaluation. When I tell you to evaluate an investment, like from this perspective, it's not enough just to get an answer like 968. You also have to tell me what that means to you. And in this case, this is a good investment because it's worth more than it costs. It's worth 968, and recall that the market price is 910. So it's good by this approach, and hopefully by now you know if it's a good investment by the PV approach, it's going to be a good investment by the internal rate of return approach. And what that's going to mean to us, of course, is that the internal rate of return exceeds the required rate of return. The required rate of return is 9.5%, so it must be that the internal rate of return is higher than 9.5%. Well, let's see. There's the valuation model set up to solve for the IRR. Notice the PV is, at this point, the price at time zero, the PV is actually an input, $910. Otherwise, we've got a $45 payment, $1,000 face value, and is 20. When we solve for I here, and keep in mind, you got to put that 910 as a negative in your calculator, then 45 and the $45 payment, the $1,000 future value, they have to go in as positives. Or vice versa, put the 910 as a positive and the 45 and the 1,000 as negatives. When you solve for I, you get 5.2368%. I left that with all that detail there. But we're going to have to double that to convert it to annual terms, and then I'll round off the final answer to 10.5%. And so since the IRR, excuse me, I've got these, well, there it is. It should say since the IRR, 10.5%, exceeds the RRR, 9.5%, this is a good investment. I'll have to go back and check that, change that very soon. There are a number of other interesting facts about bonds. I'll tell you what, I'll pick up here on the third video, and that's it.